Welcome, ladies and gentlemen. This is CS Internship. I am Alireza Alizadeh, and this is my step one presentation. What I'm going to do is basically go through the whole step, the study items, the tasks, and tell you about what I've learned, what are my thoughts about them, and we're going to go through them one by one and see where that takes us. The first thing that I did regarding this step was to study the study items, and there was a book. It's the Quick Python book. It was a book that I was reading for the first time. I'm personally not one for programming books, so I usually shy away from them or just resort to documents and stuff like that, which was a surprise that the documents weren't included in these study items because in my mind, like after you start a little and go past the hello world, stage of programming, you refer to the documents to know more about the functions and stuff like that and search it a bit. The Quick Python book was a very well written book. I was pleasantly surprised reading it. And I don't think I have the permission to show it due to copyright laws, but it was very well written. It was very well structured. I liked that it didn't shy away from complex examples in the beginning chapters of the book. It kept things real. It kept things let's say usable and actual code that you might use in your programming. And it was just you know accompanied with a disclaimer that you're not supposed to understand all of this right now, but other than that, this is useful code that you might need to know. So that's basically summarizes my whole uh, all of my thoughts about the book and stuff like that. But it was all right. I mean, as I said, I'm not a big fan of books for programming, but as far as programming books go, it was the first one that I didn't want to pull my hair out after a couple of chapters. So that's a good sign. After that, we are presented with some documents to get started with Python, which is nice. It's a nice introduction, but the first document is a bit outdated, if you ask me. And I just think that there are some things in it that are not very necessary. For example, right here you can see notes about Python 7, Python 2.7, and Python 2 versus Python 3. I don't think anyone in 2025 is going to go out of their way to install Python 2. And if somebody has Python 2 on their system, basically knows all of this by now. So, yeah, I don't think that part is necessary. One thing that was really interesting to me the first time that I learned Python, what I did was shy away from virtual environments basically and VNVs in general. So you have this VNV. The idea is you have a container for every project, right? So I shied away from this. However, now revisiting the idea and installing a new Python version because I wanted to update my old Python, but I didn't want to lose my packages and stuff like that. So I decided to just have two Python installations on my system. The idea of a virtual environment is very interesting. So the idea the idea is you have containers, right? You have a container for your project. So this is your project one, which has some code and some packages, but it's isolated from the rest of your computer. This package is just for this project. And you have another project, for example, project 2, which you have in a separate container. And this project has its own packages and libraries and its own piece of code, but this is also isolated. The reason that I shied away from this approach is when I was started programming, I was still in college, and a lot of the time you need like the same package to be multiple projects. Like I wanted this package here, but now I had to reinstall it using pip, and it was a bit of a hassle. So I decided to just roll with it and install everything globally, which created some problems because when you do this and do everything globally, sometimes what happens is, for example, you have three different packages, right? One package, two package, and three package. And when you go to update them, they don't play nice. These two going to a bit of an argument and you can update them because of their dependency, then these two have an argument and you can update them because of their dependency. And this problem just grows and grows as your number of packages grow. And that's a not a very nice experience to navigate all of that, especially when pip currently doesn't do any automation in regarding to conflicts and you have to do them by hand, and it's a bit of a process. So this time I'm like using this approach of virtual environments, which is very nice right now. It's something that Rust introduced me to, and their cargo package manager basically forces you to do this, and it's a recommended way. And as the document suggests, it's the recommended way here too, but I didn't do it back when I was in college. But installing another Python interpreter and having two Python versions on your system comes with its own challenges. For example, how are you going to manage packages and how are you going to use them, separately when you have both of them? And it led to some learning that was really interesting that I'm now going to share with you guys. So basically, when you install a new version of Python, it's the default version. So if you do py-v, that's the latest, so 3.13.3. But what if I have an old project that I need to run on another version? So what you do is, let's do this so it's more readable. You just do the same command, but this time you add the version that you want. So now you have another version of Python, which is really handy, especially when you have old projects like I do. So I can run the ones that I want with this one and run the other ones with that one, which is nice. And this is something that I had never encountered, and it was the first time that I needed to do this basically. After this was the challenge of installing packages. For installing packages, again, there is a very nice solution. You do pip and the version that you want, and that basically runs with the same version that corresponds to that. So for example, if I run this is the packages that my new version and my latest version has, and if I do 3.11, these are the packages that my old installation has, which are a lot, as you can see, and a lot of them don't play nice with each other anymore. So this is basically a snapshot on my computer and just stays this way, never updated, because if I update anything, it's gonna break. The other argument that was in this part of studies and stuff like that was that we were comparing Python to different languages. So for example, a language that is compared to in the book is C. So you have C and you have Python here. A general rule that we have in programming is that the more time you spend on coding, so you have this factor of time spent coding, right? Basically how much time you're spending on your algorithms, on your flows, workflows and stuff like that, and how much you're thinking about the structure of your program. Then you have an exit time or an execution time. Generally, we like to say that these have a relationship together, and the more time you spend coding, the less time it's going to take to execute. And this is the case in C. When you're writing a C program, you might write multiple lines, a lot of lines, and you achieve a task, but it's going to run faster. However, in Python, you might write one line that does the same job as your C program, so these are doing the same thing. However, you're spending a lot less time writing it, but that usually results in a higher execution time compared to languages like C. So keep that in mind. Although it's not written in concrete, it's a general rule. So there's a joke that yes, C is faster than Python, but is your C faster than Python? My C, for example, is not faster than Python. If I was to write, something in C and then write the same thing in Python, my Python would be probably faster because I'm not very good at writing C. So there is that, and I think that concludes the study items and the things I wanted to say about them. After that, there is an introduction to Git, which we have with, I think, an IBM video first. Let's check that. Yeah, we have an introduction to Git, which is an IBM video, and the summary of this video in general, like what you take away from it, is Git and GitHub or GitLab are the same as cars and car parks, basically. So you have this, like this versus that is the same as this versus that. You have a lot of different repositories in Git that are then pushed to GitHub or your own Git server. GitHub is just a cloud solution for storing Git repositories. And same with cars. You have many different cars, but if you want to store them somewhere or let other people see them or work on them, you leave them in a car park and they pick it up, basically. So that's the whole video for me, at least in my mind. That's how I summarize that video. Git versus GitHub is the same as car versus car park. After it, there's a Git handbook, which is basic Git commands, basically. You can see here it's Git init to initialize the repository, clone, add, commit, status, yada, yada, yada. And these are very good basic commands to begin to start your Git journey with. However, I would have liked another command to be included in these, which is not, and that's git mv. Git mv, basically what it does is, let's see what it does actually. If we do git mv.h, so here's how you use it: source destination. Basically what it does is move a file or rename it. And when you write a program and you're like in the gist of it and you're not really thinking about what you're naming stuff and what your file structure is, you might write something and name it test.py. It's a Python file called test, but then you work on it commits later and you commit to this file and you roll with it. But now that everything is done and you're left with your latest version of this, you need to rename it because you don't want to push it to a repository named test, so you do like git mv and you do git mv test.py and, for example, main.py. Because personally, when I code, I like to get things done as much as I need. Then I come back to it and restructure it so it's more compliant to industry standards and so on and so forth. So this git mv is very useful for me, at least, because I never start with a main, and sometimes that's a bit weird when you have a committed test.py on your main branch or master branch. So that's my input on that particular file and our git commands and stuff like that. Then we have a Fireship video, which was a pleasant surprise again. And this video is a practical solution and an example in use, basically how to use Git a bit more in depth. And this is how you do your normal stuff of adding, committing, pulling, pushing, and stuff like that. One thing that I would like to add to this video is that if you have GitHub Desktop installed on your PC and you're logged into your GitHub account, this automatically configures your Git configurations, and configuration files are all sorted for you, and you don't need to add your email and password and SSH keys and stuff like that manually. So if you don't want to do that, maybe that's a good solution for you. Just install this, log into it, and everything is taken care of for you. And that's that. After that, there are some tasks that you need to do. Some of them are trivial, like create an account and, do this, do that. And some of them are not, like Stack Overflow, but I won't be talking about a Stack Overflow tonight and the tasks regarding to it because I don't think there is much to talk about it, to be honest. And but we're going to talk about Typing Club, which was nice. It's about learning how to type with all of your fingers. And something that I learned and something that I encountered was that my right hand doesn't like typing. And when you're on a small keyboard like I am, because I'm on a laptop which has a full keyboard with a numpad and function row and everything like that. So my keys for typing and my alphabet are a bit cramped, to be honest with you. And what that does is results in this when everything is cramped. These are my stats for my typing task. And as you can see here, my left hand is not doing very good and it doesn't have enough accuracy. But I like the idea of typing with 10 fingers. Sometimes I use my ring finger instead of my pinky. Just use this to press P instead of using my pinky, because sometimes that when you're on a small keyboard ends up here instead of here. So that's a bit of a workaround that I've come up with. And let's talk about our task now, because I don't think there is a lot to talk about in terms of typing. The last task basically was to do some programming, right? Your basic hello world, two for raindrops. These are basic like exercises that you need to do. And they're pretty standard. There are no really many notes about Hello World and Raindrop, but 2 for was interesting because it teaches about some stuff that I find very valuable. It teaches about default values. So when you're writing a function, you have a default value for your inputs. So for example, you have foo and you have a, and you have a default value for the sub 2, for example. Or you have a default value of 3 and so on and so forth. This is, I think, a very good thing to learn early, and it helps with your functions and how you write them and restructures your brain in a good way. Another note that I have about the last task, which is this task, in my opinion, because these are not really, there isn't much to talk about them. This is basically just do some work in terminal, and these are just, more socially engaging than, technically engaging. This website that we have here, which I'm not sure how to pronounce, to be honest, exercism.io, I don't know. It doesn't sound good when I say it. And is that they run every code that you submit through Pylint, which links it and says, hey, you might want to change the name of that variable because it doesn't conform to the Pythonic style that we have. And the argument that I'm raising against this, especially in the first step, is that the argument of having clean code and having code that's done and does everything that you want and is functional. So this is something that in my opinion, it's better to focus on being done. You get a functional code, you get a code that does everything that you need, passes all the tests, and then you go back and clean it up. But when you have Pylint actively with you, like you have in this website, what that does is basically forces you to write clean code from the beginning, which is good. I'm not saying it's a bad practice. I'm just saying I prefer to have a functional code and then go back and clean it up, since you have a lot of tools to automate that cleaning, like AutoPep 8 and so on and so forth. But you don't have many tools to get the job done for you. So I think it's better to focus on this and then go back to this. I think that's all I had to say, and I hope you enjoyed this presentation. If there are any questions, I'm here. But if not, thank you for listening and thank you for participating.